See, integration is nothing but the reverse process of differentiation. What does it mean? If derivative of f of x, you differentiate a function, you get another function. Let us say it is g of x. Then same thing can be written as integration of g of x with respect to x is equal to f of x plus c. Here c is known as the constant of integration or integration constant. So if derivative of function f of x is g of x, then integral of g of x is known as f of x. This is the basic definition of integration. So these are the list of standard integrals: integral x power n dx, integral x power n dt x power n plus 1 by n plus 1. Integral 1 dx x. Don't forget to add constants. Integral k dx, where k is a constant, k can be taken off. Integral k dx can be written as k times integral 1 dx. Integral 1 is x plus c. Next, integral 1 by x log mod x. Integral 1 by x square minus 1 by x. Integral 1 by root x, 2 root x. Integral secant square tan x. This is integral secant x tan x. Integral secant x tan x is secant. There is a small error. Integral secant x tan x is secant x plus. Integral root x. See, root x is nothing but x power half. And use integral x power in formula of ln. So tan is equal to half being 2 by x power. Integral e power x dx, e power x plus c. Integral log x log x minus x plus c. Integral a power x. A power x by log a base c. Log a base c plus c. Here, e should not be there. Integral sin x minus cos x. Integral cos x, not cos x. Integral cos x is sin x. Integral cosecant square minus cot. Integral cosecant x cot x minus cosecant x plus c. These are the list of standard integrals which you need to remember. It's integral tan x. Log mod secant x or minus log mod cos x. Integral cot. Log mod sin x or minus log mod cosecant x. Integral secant x dx. Log mod secant x plus tan x plus c. Or log mod tan pi by 4 plus x by 2 plus. Integral cosecant x. Log mod cosecant x minus cot x or log mod tan x by 2. It's integral 1 by root 1 minus x square. Sin inverse x plus c or minus cos inverse x plus c. Integral 1 by 1 plus x square. Tan inverse x plus c or minus cos inverse x plus c. Next, integral 1 by integral 1 by mod x root of x square minus x secant inverse x plus c. Or it is minus cosecant inverse x plus c, both are. Integral 1 by root of 1 plus x square. Log of x plus root x square plus 1. Integral 1 by root of x square minus 1. Log mod x plus root of x square minus 1. Integral mod x. X mod x by 2. It's derivative of integral of a function. See, when a function is integrated and then differentiated, you get the same function. Because as I said, integration and differentiation are both of opposite process, reverse process. So when a function is integrated and then differentiated, you get f of x. Observe the difference between this. Here, function is differentiated and integrated. Then you get the same function plus c, because the final process is integration. Whenever the final process is integration, as I said, constant should be there plus c. Here the final process is differentiation, so c will not be there. So observe the difference between this. Next, integral f of x whole power n into f dash f of x whole power n plus 1 by this. Integral f dash x by f of x log mod f of x. Integral f dash ax plus b f of x plus b by a. So you have to divide with x coefficient. Integral 1 by root of a square minus x square sin inverse x by a. Integral 1 by root of x square minus s square log mod x plus root of x square with s. Every standard result is very important. Next, integral 1 by root of x square plus a square log mod x plus root of x square plus s square. Integral 1 by x square plus a square 1 by tan inverse x square. This should not be there. Next, integral 1 by a square minus x square 1 by 2 log mod a plus x by minus x. Integral 1 by x square minus s square 1 by 2 log mod x minus a by x plus. Next, integral root of a square minus x square x by 2 under root a square minus x square plus a square by 2 minus x by a. Similarly, integral 1 by x into root of x square minus a square 1 by x secant inverse x by a. Integral root of x square minus a square x by 2 root of x square minus a square minus a square by 2 log mod x plus root of x square minus a square. Integral root of x square plus a square x by 2 root of x square plus a square plus a square by 2 log mod x plus and root x square plus. Next, if u and v are functions of x, this is known as integration by parts. U in method. Integral uv is equal to u into integral v minus integral of integral v into u dash. This should not be there. Here u is known as first function, v is known as second function. First function as first alphabet of I later. I stands for inverse functions, L for logarithmic, A for algebraic, A for trigonometric, E for exponential. So, whichever letter first comes, that should be taken as f of x, and the other one should be taken as. For example, suppose if the question is like this: x cube into log x. Here, this is algebraic function, this is logarithmic function. In I later, which letter comes first? L comes first. Therefore, this should be taken as u, and this should be taken as v. Next, integral uv. U into v1, v should not be there. U v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on. Where u should be polynomial and v can be either right. U into v1 minus u dash into v2 plus u double dash into v3 minus and so on. Dash denotes derivative. v1, v2, v3, so on denotes integrals. Next, integral e power x into f of x dx. Here f of x is a polynomial x. Integral e power x f of x is nothing but e power x into f of x minus f dash x plus f double dash x minus f triple dash x and so on. For example, let us say you have e power x into x cube. This is e power x into polynomial. This can be easily written like this: e power x into that polynomial f of x minus derivative of x cube 3x square plus derivative of 3x square 6x minus derivative of 6x 6 plus derivative of 6 will be 0. So alternately, I write derivative and change the sign. This is very important. Integral e power x into f of x plus f dash x. E power x f of x. Next, integral e power x into sin of bx plus e power x by a square plus b square into a sin bx plus c minus b cos bx plus c plus k. Next, integral e power x into cos of bx plus c. E power x by a square plus b square into a cos bx plus c plus b sin bx plus c plus c. Next is very important point. If the integral contains root of a square minus x square or 1 by root of a square minus x square, put x is equal to a sin theta or a cos theta. When you have a square plus x square and 1 by root of a square plus x square, put x is equal to a tan theta or a cos theta. And if you have 1 by root x square minus x square, have x square minus x square, or root of a minus x square. Here, for this, put x is equal to a secant theta or a cosecant it. That is interesting. And if given integral is, if the given integral contains root a minus x by n plus x or root a plus x by n plus x, put x is equal to a cos 2 theta or a cos theta. Next, under root x by a minus x or under root a minus x by x, put x is equal to a sin square or a cos. For this, a tan square, a cos square. Root of x minus a by b minus x or root of x minus a into b minus x or 1 by root of x minus a into b minus x. Put x is equal to a cos theta plus basis. Okay. Next step, given integral is in any one of these three forms. X plus ax square plus bx plus c has sum or difference of two parameters. Next step, given integrals is of the form. Look at these three forms. Then the substitution is put px plus q is equal to a into derivative of ax square plus bx plus c plus b. If given integral is in this form, integral 1 by px plus q into root of ax square plus bx plus c, put px plus q is equal to 1 by 2. Next step, given integral is in any one of these forms. You have px plus q and ax plus b, both are linear functions. Root of px plus q by ax plus b, ax plus b into root of px plus q, or 1 by ax plus b into root of px plus q, or integral ax plus b by root of ax plus q. Remember the function inside the square root. What is the function inside the square root of all this? Px plus q, that should be taken as c square. Here also same. So px plus q is equal to this. Next, if given integrals is of the form 1 by a plus b sin x or 1 by a plus b or 1 by a cos x plus b sin x, then let's see, then put p is equal to tan x by 2, and dx will be 2 dt by 1 plus t square, sin x will be 2t by 1 plus t square, cos x will be 1 minus t square by 1 plus t square. If given integral is of the form integral a cos x by a cos x plus b sin x plus c cos x plus d sin x, then remember the shortcut formula ac plus bd by c square plus d square into x plus ad minus bc by c square plus d square into log modulus denominator. This is a shortcut formula. Procedure is put numerator is equal to a to derivative of denominator plus b. Next, if given integral is of the form, observe the difference between these two. Here, there is some constants. There's not one. So the difference between these two is the numerator and denominator are constants k. In such case, put numerator is equal to a into derivative of denominator, b into denominator plus some constants. Next shift, given integral is of form a power x plus b power minus x plus c power x plus d power minus x. Put numerator is equal to a into denominator plus b into derivative of denominator. The formula you can remember this. Next, given integral is of the form integral 1 by a cos square x plus b sin square x plus c sin x cos x, or 1 by a plus b sin square x, or 1 by a plus b cos square x, or 1 by a cos x plus b sin x whole square. Then divide numerator and denominator with cos square x and put tan x is equal to this. Next, integral f of sin 2x into sin x plus cos x. Put sin x minus cos x is equal to t. If integral is f of sin 2x into sin x minus cos x, put sin x plus cos x is equal to t. Integral f of x plus 1 by x into 1 minus 1 by x square, put x plus 1 by x is equal to t. If integral is f of x minus 1 by x into 1 plus 1 by x square, put x minus 1 by x is equal to t. Next, look at this. If given integral is of this form, integral 1 by b plus a sin x by a plus b sin x whole square, then divide numerator and denominator with cos x. When you have sin x, you have to divide with cos x and put A secant x plus b tan x is equal to. Look at the next point. Here the function containing cos x, and you have to divide it to sin x. You have to put a cosecant x plus b cot x is equal to. Next, these are based on reduction formula. If in is equal to integral x for n equal to x, then I is x for n equal to x by a minus n by a in minus. All these are the reduction formula. Integral log x all power dx. X into log x all power n minus n by n minus. Integral sin power n x. Integral sin power n x. Minus sin power n minus 1x cos x by n plus n minus 1 by n in minus 2. And it will be like this. Minus sin power n minus 1x cos x by n plus integral cos power n minus 1x n x by n plus n minus 1 by n. Integral tan power n minus 1x n minus 1 minus in minus 2. Integral cot power n minus cot power n minus 1x by n minus 1 minus in minus 2. Or for these two, underline in plus in minus 2 is equal to tan power n minus 1x. For the second one, similarly, integral secant power n x. Secant power n minus 2x tan x by n minus 1 plus n minus 2 by n minus 1 in minus 2. Next, integral cosecant power n x. Minus cosecant power n minus 2x cot x by n minus 1 plus n minus 2 by n minus 1 in. Next, integral sin power mx into cos power mx. There are two results. First one is minus sin power m minus 1x cos power n plus 1x by n plus n plus m minus 1 by m plus n I m minus 2 comma n. Second result is sin power m plus 1x cos power n minus 1x by m plus n plus n minus 1 by m plus n I m comma n minus 2.